Hi, welcome to my channel Education for Aspirants. Today I am going to discuss the concept of heap tree and its types. To understand the concept of heap tree, one should know the concept of complete binary tree before. In this video, I will be covering few GATE questions related on this concept, so watch the video till the end. Let's start the session with the concept of heap tree. A tree T is said to be a heap tree if it is satisfying the following two rules. One is it should be a complete binary tree, and second rule is the value of a parent node is either greater or lower from all its descendant or child nodes. First we will discuss what is complete binary tree. When we are inserting the elements in a binary tree, if the elements are inserted into the tree in a left justified way, then such binary tree is called as complete binary tree. For example, let the binary tree is like this: A, B, then C. It is an existing binary tree is there. Now I will insert D. So if I will insert D, I should insert D in the third level, right? So in this level, I should start the insertion from the left part of B. Means I will insert D in the left of B. If I will insert E, then it should be in the right part of B. Clear? Like this we will insert. So if we will insert the elements in that level from the leftmost onwards, okay, left to right, then such type of insertion process is called as left justified insertion. For example, let I will insert an element F in the right part of C. Let I will insert F here. If I will insert F here, then it violates the rule, because the left part of C is till now it is blank, right? So by leaving the left part, we cannot insert in the right side of a node. So if you insert like this, then it is not called as a complete binary tree, it is a binary tree. But if you insert all the nodes from left to right, then that is called as a complete binary tree. So if the binary tree is a complete binary tree, then we can say that tree is a heap tree. Then what is the second rule? The second rule is the value of a parent node is either greater or lower from all its descendant node. Descendant node means what? For example, let A node. For A node, how many child nodes are in the lower part of A? All the child nodes of A is called as descendant node of A. In this figure, for A, B, C, D, E and F, all are called as descendant node. Clear? Similarly for B, the descendant node is D and E. I hope understood. So as per the second rule, it is saying that the value of a parent node is either greater or lower from all its descendant nodes. So let's see here one example. In this example, 77, the value of 77 is higher from all its descendant node, right? Similarly, the value of 42 is greater from 12 and 13, and the value of 56 is greater from 14. So that's why in this heap tree, the value of a parent node is greater from all its descendant node, right? Similarly, so in this figure, the value of parent 17 is smaller from 32, 26, 52, 43 as well as 34. And in this subtree, the value of 32 is less from 52 and 43, right? Similarly, in this subtree, okay, the value of 26 is less from 34. Means the value of a parent node is small from all its descendant node in this figure, and in this figure the value of a parent node is greater from all its descendant node. That's why you can say this tree, these two trees are heap tree. Okay. Now we will discuss the categories of heap tree. Normally the heap trees are divided into two different categories. One is called as Max-Heap tree, second is called as Min-Heap tree. What is Max-Heap tree? If inside the heap tree, the value of a parent node is greater from all its descendant nodes, then that type of heap tree is called as Max-Heap tree. In this example, the value of 86 is greater from 42 as well as 77, and the value of 86 is greater from all its descendant nodes, right? Now if we come to this subtree, in this subtree 42 is the parent node and its descendant node is 12 and 13, right? So 42 is greater from 12 and 13. Similarly, if you see this subtree, in this subtree, the value of 77 is greater from 56 as well as 57. Hence, you can say 77 is greater from all its descendant node. So, you can say that heap tree is called as an Max-Heap tree. Similarly, what is Min-Heap tree? Exact its opposite. In a heap tree, the value of a parent node is less from all its descendant nodes. Then that type of heap tree is called as Min-Heap tree. So, let us see an example. In this heap tree, 12 is less from all its descendant node. Similarly, if you see this subtree, in this subtree, the value of 42 is less from 77 as well as 56. So, that is why you can say that is also the value of parent node is also less from all its child, right? In this subtree, the value of parent node 13 and it is less from 86 and 57. Means in all subtrees, the concept of the concept is satisfying. What is the concept? The value of a parent node is less from all its descendant node. That's why that type of heap tree is called as Min-Heap tree, right? Clear? Now we will move to discuss few GATE questions. So this is the question of 2006. It is asking, in a Max-Heap tree, what is the time it will take to find the smallest element inside the heap tree? So let's consider one example here. This is the example of a Max-Heap tree, right? You know that in a Max-Heap tree, the highest value will be present at the root, right? And always the smallest value you can find at the leaf level. Clear? The smallest value is 13, right? So where the 13 present? At the last position, right? Last position means what? That is the last location in the level, right? So how will you find this node? You need to move from the root onwards, right? First you will check root, then you will check 42, then you will check 77, then you will check 15, then you will check 38, then you will check 57, then at last you will check 13. And when you will find 13, so you will stop the process here. And if it will take one time to search one element, and inside the tree, if n elements are there, then to search that location, how much time it is taking? N time, right? Because to search one element, it is taking one time, right? So if inside the tree n elements are there, then how much time it will take? N time it will take. So what is that complexity in the worst case? So the complexity in the worst case is big of n, right? Big of n. So what is the answer for this question? That is big of n. Similarly, if the question is like this, in a binary Max-Heap tree, how much time it will take to find the maximum element? What you will say? That is for maximum, that is big of 1. Why big of 1? Because you know that in a Max-Heap tree, the higher value will be present at the root. So it will take only one time to search that root. So that's why for maximum, big of 1. For minimum, that is big of n. I hope understood. Next we will move to the second question. Now, this is the GATE question of 2004. The question is, the elements 32, 15, 20, 30, 12, 25, 16 are inserted one by one, clear, into the Max-Heap tree. Then what is the resultant Max-Heap tree from the given choice? It is asking. So let's start. First 32 will insert. So when we will insert 32, there is no element present, right? So 32 is the first element. Then when I will insert 15, you know that, so we should insert 15 as the left part of 32. Then we will insert 20. 20 means in the right part of 32. Clear? Now we will insert 30. So when we will insert 30, we will insert 30 in the left part of 15, right? So after insertion of 30 here, you just check as per the Max-Heap rule, the value of a parent node, it should be greater from all its descendant node, right? But here, if you see 15 and 30, the value of parent node is less from 30. So what you need to do? You need to interchange. Clear? The higher value should come to the parent and the lower value will shift to the child. So if you shift it, you will get here 32, then 30, then here 20, then here 15. I hope understood. Next we will insert 12. If you insert 12, 12 will insert here. Then check 12 is less from the parent or not. Yes, 12 is less from the parent. Then no problem. Then we will insert 25. When we will insert 25, it should come in the left part of 20, right? But if you see here, 25 is greater from the parent node 20, right? So what you need to do, as per the Max-Heap tree, so the parent node should be higher value. So here we need to interchange the value of the parent node and child node. If you interchange, you will get here 32, then left part is 30, then right part is 25, because we will shift 25 to the top, to the parent. Then now this 30 left is 15, then 30 right is 12. Clear? Now, so though 25 and 20 shifted, so 20 will become the left of 25, right? Then now, so the last node will insert 16. So 16 will come in the right part of 25. So after insertion, the heap tree will looks like in this way. Clear? Now you check which choice is matching. 32, 30, 25, 32, 30, 25, then 15, 12, 20, 16. 15, 12, 20, 16. So A choice is matching, right? So though here the choice A is matching, that's why the answer for this question is A. In this lecture, I covered the concept of heap tree and its categories. Hope everybody understood it. So in the next lecture, we will discuss the heapify method to build a heap tree. Thank you.